remember when doing transformations, that each point is moved. But the overall shape is the same. Okay, what I mean by that is, if you have a cubic and you do a vertical stretch or a translation, it's still going to have a little hitch in the middle like this. It's still going to be a cubic, that's what I'm saying. Okay? If you have a parabola, which you've done lots of in grade 10 and 11, it's still going to look like a U or an upside down U no matter what sort of transformation you do to it. Okay? So the base shape. The things we're going to have to remember. Those are the base shapes of all the functions, okay? There will be transform, they'll get things moved around, but that when we did this, remember the first day, we went the first day of class, the second day of class, when we got to the graph and calculators. The only thing we're going to talk about, and I'm going to do this in red, I'll get out of the way here, so I'm too excited, okay? Is we're going to talk about the vertex or the point of reflection of all these graphs, because that's the thing we're going to key in on, okay? Okay, for all of these, there's a nice point. What's the vertex or the point of reflection for x squared and x to the fourth? What's the vertex going to be? Don't give up, guys. You can do this. What's the vertex or the point of reflection of x squared? Good. Thank you. 0, 0. Okay. That is a key point. Here also is going to be 0, 0. Okay. All that's going to happen then is we're going to be moving that point up, down, left, and right, and the arms will follow. Right? The same thing, it'll be compressed and stretched sideways from there and flipped and all that stuff. For the odd functions, x cubed and x fifth, this point in the middle is what? Not a trick. Go ahead, Brian. 0, 0 as well, too. Okay. So that's going to be the point where you're going from concave up to concave down. I hope I said my science right. Curvy this way to curvy this way. Concave up, concave down. You're not hearing physics? Forget it then. Okay. The point is, though, curving this way, and it's going to inflect. Let's see what happens here. Okay, back from grade 11. Also, I'm going to say, remember your transformation rules. Yeah, too warm in here. Also, my mind has gone to mush, so this was on my note for the first day. I don't know if you actually got through it or not, though. Do we go through the y equals a after k x minus h? We'll do that one? Okay. Good thing it's on today's note, too, then. That should hopefully look familiar from grade 11. If you don't know what the letters, you don't have to memorize that ever, but you need to know what each thing means. What is the A value to the left mean, please? I should pick on somebody else in my class here. Really? What does that name mean on the left side of the transformation, if you remember? Multiply, okay. So A is going to be your vertical stretch. Going to be multiplying y's and values by a. Okay, so if you're looking at x squared versus 3x squared, what that's going to mean is it's going to be 3 times higher. Okay. All right, what does the k mean then? If I say f of bracket 2x, I'm picking on usage your next in line. Do you remember what f of bracket 2x would mean? Right. So B is going to be a, do you want to call it compression or a stretch of one over? You guys are right on top of it. 3 mistakes is all I need to make in one day. Okay, so it's a horizontal compression of 2. It means you're going to divide your values by 2. That's what it means. For multiply by 1/2. Yeah.
Is the K the absolute value of K? Like, if it's a negative, does it do a horizontal?
Negative would be the horizontal flip. Yes, yes. P is going to be what? Calendar, recall what the P means inside the bracket there.
Is P and Q not for, it's written?
Yes, it is for parabola. Okay. Do you remember him? Okay, go ahead. Yeah, horizontal. Sorry, I hate putting you guys on the spot for this because this is mean, because this is just memory, that's all this is, so don't worry about it. Horizontal translation. And we're going to say P units left. Okay, so it's going to be in the opposite direction. Okay. And Q is going to be the vertical translation. Yeah, this is opposite. So anything to do with X is the opposite. Think of it like you're solving minus. Yes. Yeah, I guess what it says here, shift to the right, yes. So, for myself, translations aren't a big deal in my life at all. I'm going to go through a few examples of you today. There will be one question on your assignment and one question on your test. Okay, this is not a hideously important part of my life. Okay, and in calculus, you'll never use this again. That's the way I treat this course. Okay, if you're never going to use it in calculus, it's probably not worth a whole lot. I'm sorry, just the way I do it. So I'll do my last things in the curriculum. There'll be one question on your test, one question on your assignment on this. Sound fair? Yes.
With the horizontal compression,
Yes.
I don't remember, but is it switched? Like, if it's a compression, is it whole number and it's stretched?
Yeah, so it's basically just thinking you're dividing it by the number. Okay, so if it's like f of 2x, that means it's going to be divided in 2. Okay, if it's f of 1/2 x, it's going to be like multiply. So you're stretching it like that. Okay, so just the opposite. Okay, here we go. Let's do a few examples. Okay, so if you had, sorry, I keep talking about Mr. Walsh all the time, but him and I do things a little bit differently. If you want to do it his way, that's fine. I do it with, he makes you graph 4 versions of the same graph. In this case, I do not. Okay, so mine I just go from the beginning to the end. If you wish to make a table, you may make a table like we did in grade 11. That's fine to do. Okay, if you want to do it using, actually want to do it with a table. I'll do it with a table. If you don't want to do a table, you don't have to. Okay, so here we go. Let's start with our original points here. If something is cubed, okay, what is, so we're going to cube those values. How do you get the y values? Play along. Please play along. Please play along. Go ahead. Right on. So it's gonna be -8, -1, 0, 1, 8. Closest come back. 2f of x is what? Yeah, keep going. So we're going to multiply y values by 2. I'm going to speed this up in advanced functions. If you don't want to speed it up, you don't have to. I'm going to go right to that if that's okay at this point. Okay, so what that is I'm doing the vertical and the horizontal translation step. These are separate. What are the transformations for x minus 3 plus 4? What does the x minus 3 tell you to do? Which one is it? Right, okay. So I'm going to add 3 to x. Sorry, I'll leave it if I'm focused. So I add 3 right. Oh boy, I'm not even here, I'm sorry. I'm going to get attacked by the apple today. Okay, so it's going to be 1 comma -12, 2 comma 2, 3 comma 4, 4 comma 6, is that right? And 5 comma 20. Now, when we graph this momentarily, it will be exactly the same shape as an x cubed function. For those who are in Mr. Walter's class, what's it going to look like though? What's the difference going to be though? Peter, go ahead.
A fully transformed function?
Yeah.
It's going to just be to the right and stretch right.
Yes. Okay. There's going to be a vertical stretch by a factor of 2. So if x cubed looks like this, it's just going to be a higher version of 0 and a narrower version of x cubed. That's what it's going to be. And instead of being a 0, 0, it's going to be a 3 comma 4. Either way you want to do it is fine by me. Okay, I have no issue with that. I'm going to graph this one because I like to graph. The way, again, just Mr. Walter, there's no difference of opinion on this. What Mr. Walter will do is he'll make you graph. They don't have them in grade 10 a lot. You probably have it in grade 10, right? When he did the parabolas the first time, right? So you have to graph. You would have to graph for this one, the standard x cubed function, then do the stretch, okay, then do the left translation, the right translation, then do the up translation. Okay? So that's a lot of work, and it's hard. The reason I don't do it is as a teacher, it's hard for me to see. I can't see one graph, no offense to mine. How some people's graphs are, but it's do 4 messy graphs on one page is awful. Okay, so that's why I don't do it that way. Here we go, 9. Now, this is a beautiful example of scale. Okay. I have to get all the way to 20. 2, 4, 6, 8, 10, 12, 14, 16. I'm going to do it. I have better graph paper than you do. Now, I had a student in grade 11. I made them actually do an x cubed and do transformations to it on one of their assignments. And what they literally did was they stapled 3 sheets of graph paper together until the numbers got up to 60. Okay? It's not funny. Like they really, like they folded it together. Maybe there was no one in this room. I don't think it was, but they literally did that. So their paper was like this, but then they only did was to staple it together. They thought they were being an excellent student, and I'm sure they thought they were. Just change your scale, please. Okay. On your tests, do I have a copy of my? This is probably the size of graph paper. Actually, less than this, probably even. Right. So less than that. What do we have to count? Because they're really small. Should we do that fair that long for? No. Most people, they weren't this big. They use small graphs. They were real tiny.
You can fit 3 in like a row.
Oh, okay.
The one you looked at, it was like a black background or something.
Yeah, you couldn't see them.
Yes.
How many like points do you want on it?
5 is probably enough there. So 0 and 2 on the other side.
Okay, and with the ones that have multiple like loops in it, you just want to.
No, because here's the thing. The ones with the multiple loops in it cannot be done with this method. That's the problem. Because there's only going to be one root of these ones if you take a look. All right. Anything based on a transformation of one of the base functions will not be funky. It'll just be in a standard shape. That's why these are less interesting to me, right? They because you can't do it. You can't. It's impossible to transform this and get that, right? Well, right, see what I mean? So you can't do it, right? So, okay. Let's go to, now please note when I'm doing this here, guys, notice I'm filling in all my numbers, all right? So please make sure that your numbers are all filled in properly. You will lose half a mark for not filling in your numbers. And yes, I know that makes me a mean person, but I don't care. That's how I am. Please also notice, if you've not been in my class before, I do not require that you graph the original function. I just want the final function. Okay? Unless I say graph the original and the new one, otherwise just graph the final function. So I have 3, 4, which is right here. I have 4, 6, which is up here. I have 5, 20, which is way up here. I have 2, 2, which is there. And I have 1, negative 12, which is down there. Okay, so this graph's going to look upwards, sort of like this. And this one's going to go down, sort of like that. And this is 2f of x minus 3. Now, once again, if you did this a different way in grade 11 and grade 10, I don't mind. You can do it that way. It will still be correct. You'll still get full marks on your sheet. As I said, there'll be one example of this on your test and one on your assignment. Okay? Because these are, remember, they're just transforming the base graph. All right, you guys want to show one yourself? I know you don't. Too bad. Example 2. Use transformations. To graph y equals 3 times 2 x minus 2 to the 4 minus 1. Now this is where, Peter, we can see that why there wouldn't be any of those nice ones, because there's a quadruple root here, or close to it though, right? I mean, like, it's something to the 4, like the exciting stuff in the bracket happens there, so there's less, fun ones, okay? So you can do this just like the last example. If